Let's continue to explore rules of differentiation with the product and quotient rules. Let's start with the product rule. Let f of x and g of x be differentiable functions. Then the derivative of the quantity f of x times g of x equals. So before we fill this in, let's talk about it. So intuitively, I would think, oh, well, since the derivative with respect to x, if I'm having the sum of formula, so f of x plus g of x, I could just take the derivative of each of them and then add them together. Same with the difference. So I bet this would be the same thing as taking the derivative of f times the derivative of g. Let's see if that's the case. So let's look at an example. Let f of x equal x to the 7th and g of x equal x cubed. Let's see if this is true, what we would intuitively think would be the case. So if I were to find the derivative of these two functions multiplied together, let's just actually figure out what that n function is. So that's x to the 10th power. And that's just using that properties of exponents, a to the m times a to the n equals a to the m plus n. All right, finding the derivative of this using the power rule, I get 10x to the 9th power. Okay, now, so there's that. We know what the answer should be. Let's see what the answer is when I do it this way. The derivative with respect to x of f of x, which is x to the 7th, times the derivative with respect to x of x cubed. Well, when I do this, I'm going to get 7x to the 6th times 3x squared, which is 21x to the 8th power. Not what it should be. This is what it should be. So I'm going to tell you now what the product rule is. So hopefully you will remember this and not try to use it incorrectly. So the power rule says if you are taking the derivative of two functions multiplied together, how you figure it out is it's the first function times the derivative of the second function plus the second function times the derivative of the first function. Another way that we could write that a little bit simpler would just be first function, so f of x times g prime of x plus g of x times f prime of x. Okay, so let's actually use that formula in this situation and see if we get this 10x to the 9th power. So the derivative with respect to x of x to the 7th times x cubed. Okay. So here's our first function, here's our second function. So this is going to be the first function times the derivative of the second plus the second times the derivative of the first. So that gives me x to the 7th times 3x squared plus x cubed times 7x to the 6th power. Using exponent properties, this gives me 3x to the 9th plus 7x to the 9th. So I have in total 10x to the 9th. That matches up. Yay! So this is the power rule. You do need to have this memorized, so make sure that you practice it. My best advice again is anytime that you actually use it, write the formula down. Let's do some more examples with this. Find the differentiate f of x equals the square root of x times e to the x. So we could treat the square root of x like f of x and e to the x like the second function g to the x. Okay, so I have two functions that are getting multiplied together. I don't have a formula for square root of x times e to the x, but I do have a formula to differentiate the square root of x, and I have a formula to differentiate e to the x. So I'm going to take each of those pieces and use the power rule, or the product rule, excuse me. So the derivative of the function with respect to x, so that's going to be the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, so this becomes the square root of x. The derivative of e to the x is x e to the x plus e to the x. I can rewrite this as a power x to the 1/2. When I do the derivative rules, I'm going to get 1/2 times x to the 1/2 minus 1, which is negative 1/2. So that gives me the square root of x e to the x plus 1/2, or e to the x times 1/2 with that x to the 1/2 in that denominator now to make that exponent positive. So that's the square root of x e to the x plus e to the x times 1 over 2 root x. I'm going to move it back to a radical since that's what the original function had in it. I'll just simplify this a little bit more. So square root of x e to the x plus e to the x over 2 root x. It's super yucky, but that is the end answer. And we wouldn't have been able to find that if it wasn't for the product rule. Okay, so let's look at a little more of a more complicated example. Differentiate f of t equals e to the t times the quantity t squared plus 1 times the quantity 2 minus 3t. Whew. So what I can do is I can treat this like one function, and then we'll treat this like the other function. I'm going to have to end up doing the product rule twice in here since I have 3 functions getting multiplied together. But so the first step is just identify one as one function and the other as another. So now we can set this up using that product rule. Derivative of the function at t, so that's the first function, which I've denoted as this, times the derivative of the second function, plus the second function times the derivative of the first function. Okay, so I can go, let's go through and do this first part. So again, you can see here, this is our second function, and this whole thing here is our first function. First function, second function. Okay, so on the left, I'm going to have e to the t times t squared plus 1. When I find the derivative of this, the derivative of 2 is 0, and the derivative of negative 3t is just negative 3. Plus, okay, so over here I have 2 minus 3t. Now, to find the derivative of this, I have a product again, so I'm going to have to use the product rule again. So now I'm going to have one function here, one function here. Okay, so it's going to be, I'm going to apply the product rule again to figure out what this entire thing is. So that's what's going in here, the derivative of that. So the derivative, so it's going to be first function times the derivative of the second plus the second function times the derivative of the first function. Oops, I don't need to print the C there. All right, super yuck. So let's just work out what's inside those parentheses. Okay, so this is going to give us, I'm going to move this negative 3 in front. All right, so I get that, plus this 2 minus 3t. All right, so let's evaluate what's inside here. So that's going to give us e to the t times the derivative of t squared plus 1. So the derivative of t squared is 2t. The derivative of 1 is just 0. So the derivative of t squared plus 1 is just 2t. And then over here, the derivative of e to the t is just e to the t. Okay, so yuck. So this ends up giving us negative 3 e to the t times t squared plus 1 plus 2 minus 3t times e to the t, 2t, plus t squared plus 1 times e to the t. I can factor an e to the t out of here, so I can just kind of write it a little bit nicer. Like this equals 2 minus, plus 2 minus 3t times e to the t times 2t plus t squared plus 1. Okay, so all I did is I just factored this e to the t out and pulled it out in front. You could keep on going with this if you wanted to, just continue simplifying it further, but I think you guys are able to see how to use that product rule 3 times if you get something complicated like this.